The lecture goes like segmental construction of bridges, segmental, or you can say the accelerated construction. So far, you have been given the knowledge about how the bridges are designed, they are constructed. Basically, the accelerated construction or segmental is a basically technique, but the overall word is accelerated, means to expedite, to make the construction faster. And process of faster construction encompass various challenges, जो कि आप यदि आप चाहें कि मैं बहुत जल्दी से ब्रिज बनाऊं और लंबे लंबे स्पैन कवर करूं, तो नेचुरली आपको उसके लिए बहुत सारी डिज़ाइन में आपको चेंज करने पड़ेंगे, कंस्ट्रक्शन मैथडोलॉजी आपको बदलनी पड़ेगी और नई नई टेक्निक आपको लगानी पड़ेगी, क्योंकि इसका कोई श्योर शॉर्ट फार्मूला नहीं है कि इसको इस तरह से हम बनाएंगे. बहुत सारे चैलेंजेस उसमें आते हैं जो आपको कवर होंगे आगे आपके टॉपिक में. तो उस पर आपको थोड़ा ध्यान देना पड़ेगा कि कैसे आजकल नया कंस्ट्रक्शन हो रहा है और कैसे जो बड़े लॉन्ग स्पैन ब्रिजेज हैं जिनकी रिक्वायरमेंट है कि साहब हमको करीब करीब 300 मीटर पे हमें पाइलॉन रखनी है या 2-2 किलोमीटर 1-1 किलोमीटर पे हमको रखना है या सी के ऊपर ब्रिज बनाना है, तो वहाँ ये पॉसिबल नहीं है कि वहाँ आप जो कास्ट इंस्टीट्यूट कंस्ट्रक्शन करें, तो वहाँ आपको इन्वेरिएबली आपको जाना ही पड़ेगा ऑन दी सेगमेंटल कंस्ट्रक्शन. सेगमेंटल कंस्ट्रक्शन में कई टाइप्स हैं दैट यू विल सी. So now this, because of the various computational IT facilities available for design, advances material, erection technologies, faster evaluations, I mean all these factors governs the choice of accelerated construction, depending on the resources that you have. So on the basis of the resources, you can always think of the type of material, like you have the steel or composite or high performance concrete or high grade steel, you know. So all these material advances like governs the type of construction. IT facilities, it's very important because earlier days we did not have the fast computation method. Nowadays we have very sophisticated software backed up by your IT tools, faster computer generation, faster generations of computer. So all these things makes life very easy to have such construction implemented at site. And obviously when all these combination comes, they give you the very good aesthetic appeal that you can always see. Type of construction means segmental, one by one in smaller segments of something like say 3 meter to 4 meter in length or width, like depending on the width of carriageway, 2 lane, 4 lane or 6 lane. So up to 6 lane, like you can go up to 14.5 meter or 15 meter segment like that, or even wider depending on the design and the ease of construction. You can go for even higher width. Launching mechanism is very important because whatever the segment you design or whatever segment you think of that it should be fitting in your cross section, we have to see what launching mechanism is adaptable for that particular design. And it's all depending on handling conveniences and the space available at site, because you have to do certain construction in urban areas, you have to make certain construction at junctions near ROBs, railway crossings. So all these location gives you difficulty in deciding the launching mechanism because there is a space constraint. And material, obviously, it should be quick, the long-lasting setting, extra high strength, and evaluations. It's very important because this is the one aspect, which you have to have very good construction control. Otherwise, you can find both the notches are not meeting at the end of the day. You would have seen certain photographs on WhatsApp or something other, like you are constructing bridge with segment by segment, and when you come to the end, it should meet perfectly. If your measurement techniques are not good, you are not able to control the construction sequence, or you are not able to control the coordinate, both ends do not meet sometime. Then you have to make adjustment. And a lot of things goes into the design also, because it's a long span bridge, like 100 meter coming on that side, 100 meter coming on this side, lot of shrinkage happens on the way. So you have to consider all these factors to make sure that wherever you find the meeting point should come close. Like in case of tunnel, tunnel में सबसे ज़्यादा आपका चैलेंज होता है, वो बोलते ब्रेकिंग सेरेमनी कुछ बोलते हैं उसमें, कि जब आपका टनल एक तरफ से आ रही है, एक तो दूसरी तरफ से आ रही है, तो दोनों में ऐसा होना चाहिए कि वो दोनों एंड आके एक जगह आके मिल जाएं. तो वो सबसे ज़्यादा टनल का हाई पॉइंट होता है. जो ब्रेकिंग सेरेमनी होती है टनल की, सबसे ज़्यादा हाई पॉइंट होता है कि जब दोनों एंड, जब वो ब्लास्ट करते हैं दोनों एंड आपस में मिल जाएं और यहाँ का लोग वहाँ के लोग एक दूसरे को देख सकें, तो सबसे ज़्यादा इंपॉर्टेंट होता है वो. Quality control, of course, you should have a good QA/QC protocols. Hindrance-free site, as I told you, I mean, whatever site that you select, it should be hindrance-free. It should be safe also from the traffic perspective, that it should not cause any accident or loss of life. As its names imply, segmental bridge is a bridge built in short sections called segments, and it is made of either steel, precast concrete, purely concrete, composite, any kind of material that is suited for the bridge at locations. And as a thumb rule, these bridges are very economical, over 100-meter span, long spans basically. We consider long span for the segmental construction. Like your balance cantilever, normally like 65 meter on other side means 130 meter. So invariably you can find this balance cantilever bridges that were used to be constructed across our, you can see the Thane Creek Bridge, Bombay, or I mean, look at the Niveta Bridge at Kolkata, where I was the project director in NHAI. I will show with that example. So all these bridges offers a very good span length. If you just look at the history, I can just miss also because it's not important. You will get my slides in any case. The first segmental bridge was built in Germany in 1950. Then first precast segmental bridge built in 1962 in France, Seine River. Then first US precast segmental construction bridge built in 1973. So you can see all these modern bridges are not very old. I mean, they are just evolving from, you can say, from last 50 years. This is how the things are changing. People thought of that after Second World War, that we should have a faster, like Europe. Europe was all fragmented in different segments. So when Second World War happens, they all became united. And unity doesn't come just like that. You have to have connections also. So to have the connections, because there are large valleys separated by seas, so they all connected. So they thought of this technology after Second World War. So that is how all this advancement took place. So precast segment comes in 1993. This technology basically developed long ago. It's not new. In India also, if you look at our old historical temples, like in South India or somewhere, they are also segmentally constructed. I mean, you can imagine the Madurai temple, where how they have taken up the segment by segment at top, because there was no natural material like rock. So it's all constructed by our predecessors, our ancestors, and those technologies were available because they also have good construction control. So that is how all these that you can see those bridges, the temples, particularly our old ancient Hindu temples. I mean, they had very, very advanced technology. At that time, they did not have the surveying equipment, but definitely they had something so that they could control the technology. And this 19th century and early developments, iron and steel truss bridge builders developed a method of constructing large bridges without use of false work. Because nowadays what we see, you use lot of false work or erection technology. But earlier days, they used to have permanent works as a false work. So they add on, they keep on adding the permanent works, and that becomes the, from here, you can see from this point onwards, they started constructing the bridge, and only precaution they took that they should avoid the tipping of the midpoints. In 20th century, this cantilever method of building prestressed concrete bridges is developed. In India particularly, if you see all these balanced cantilever, it is called Russian technology, where in 1970s, starting from 71 to 78, all these balanced cantilever bridges constructed. So it was a fashion at that time in ministry to have the balanced cantilever prestressed concrete bridges. So I'll just skip this slide. You can just look at it. I don't want to. After 70s, people thought of, look, 100 meters is not enough. We should have even larger. But then the computational challenge comes. You have numerical method always. They used to compute by hand. But when it comes to very large span, like something like more than 200 meter, 300 meter, center to center, then they say, look, we have to have something, a computational tools in our hand, so that we can go for even larger hand. So as the computational technology improved after 70s, lot of new software started developing. Your computer age was also getting modified. So that will really facilitate the computational methods and vis-a-vis the implementation of the bridges. Precasting, of course, precasting offers a very good solution. because they can, you can have, I mean, good quality control at site. Then another challenge was how to transport that precast segment to the site. So that was also a great challenge in India, something like 10 to 15 years back, because all this, trailers, you have to have something like 25 to 30 meter long trailers to carry the segments, because your segment width is something like 6-lane segments. 6-lane segment means almost 25 to 24 to 25 meter wide. So how to carry those segments? And I still remember when flyovers was constructed in Delhi in, you can say, middle of 90s, we did not have a launching mechanism more than 25 meter. You can imagine. I mean, there was no crane available in Delhi which can launch the single girder of 25 to 30 meters, more than 25 to 30 meters. So that's the constraints that we face, you know. So that is how the technology evolved. Now we are easily doing construction methods like span by span. This is the one method where you can have entire span of segment supported by temporary truss of girder until it is post tension and self-supporting. Because then we take the advantage of pre-stressing. So you just have a total span, one span of 25 to 30 meter, entire span in one go, put it on the support, first temporary, then permanent, and then pre-stressed it, like that, span by span. You have full truss, given full load on the piers. So piers have to be designed like that, because this is a design challenge, because it has to handle both temporary load during the erection and then the permanent loads. So you have to design that way. And then you look at the traffic below. So, I mean, this is the challenge. I mean, God forbid the accident happens, but we engineers take the challenge. We take the, whatever it comes to. It has happened in Las Vegas, Nevada, US. Fortunately, no accident happens, but they make sure that this technology gives you the confidence that, look, we can construct the bridge while we don't want to stop the traffic also. That's the confidence that one should have. Then cast in place span by span. Like you have a already gutter available, then just move your truss, then put in the place. Then progressive placements, multiple span. You are able to put the multiple span in one heading. Then incremental launching, like multiple span, one by one. I'll show the example. I don't want to spend much time here. Now recently we had bridge at Chenab, on river Chenab. This is the world highest bridge in India. It is more than the height of the, it's not that bridge, it's a different bridge. But I could have included that slide, but I have not included that. So that's the one challenge that India has accomplished. So normal sequence goes like build the support towers, columns, build the temporary false work, because you have to have a temporary supports, then build the deck and perform the finishing work. If it is designed like pre-stressed, then go for post-tensioning. Support towers also can be built segmentally, because towers height normally, I mean, depending on your design of the bridge, design of the valley, your support towers may also be very tall, something like ranging from 10 meter to 20 meter. We can have, I mean, often there is a accomplished using slip forms, because you can either use slip forms or you can use the one pour method. And normally you can see in the metro pillars which are not very high, they use normally the single pour, because it gives you very good finishing, like single pour pier, one cast. So I'll come to the, of course, the cost. Actual cost of segmental bridge can vary widely with following consideration, like span length. So you have to select the span in a manner that, I mean, your longer spans have higher per square foot cost, definitely. It will have a higher cost. Project size, because if your project size is, I mean, if it's a big project, it's, I mean, a kilometer long or then more than 1,000 meter or 2,000 meters, it gives the economy. Site access is very important, because especially in urban areas, you have to really see that the segments that you are carrying to the site is really, I mean, your roads are approachable. I mean, you have the trucks which can really ferry your segments. Then geological condition. You should not have too much rain, or like if it's a hot and humid, you should also consider that in your design. This is the view of segmental construction. Like construction control, which I was talking, is very important that both the arms, this arm and this arm, you should have a perfect control so that this is matched perfectly at the end of the day. This is another method. This is span by span, like that. Look, this is the 298 meter span. This is the Ralph Sundet Bridge. I think it's in Germany. The main span of bridge is to about 298 meters. So this is the beauty of that particular bridge. In Florida, it's I mean, you can see one temporary support. All these spans are ferried. Then this is the in Richmond, in France, I think. This is the extra dosed cable stay bridge, where the box girder with 630 feet, about 225 meters, something about 200 meters. Just look at the beauty of the aesthetics, beauty of the bridge. Here you can see they are, I mean, like in India, we used to have a, the bearing or you can say expansion joint at the tip. But here they use the continuous kind of construction to avoid the expansion joint, like modular expansion joint, like Mr. Garwar was mentioning. So we try to avoid as much as possible. In Bangladesh, there was a Jamna Bridge. It's a big bridge, dual two-lane carriageway. It gives the, railways as well as natural gas pipeline, telecommunication, everything that this bridge has. It's a very long bridge on well foundation system. You can see the cross section. It's about 6.5 meter box, like that. And this is the one bridge that, in fact, is my own personal experience that we constructed at Second Vivekanand Bridge. If you have gone to the Calcutta near Dachineshwar, there was an old bridge, Bali Bridge. In parallel to Bali Bridge, we constructed this bridge on NH2, Dankuni Junction. This was a part of Golden Quadrilateral, and this was the first project which was built on built operate transfer basis, BOT basis. First standalone bridge project in India. It was constructed by Parkinson Brickman of US, CS, and the client was NHI. And fortunately, I constructed this bridge as a project director up to 60% of the progress of the project. It's a huge bridge, basically, a main bridge of 880 meter single lanes, 6-lane bridge, 880 meter, having the 11 span, totaling 6.1 kilometer, including the approaches and the viaducts, approach viaducts, 2-lane, 4-lane, 6-lane. This bridge has all the features, like it has extra dose cable stay bridge, it has 2-lane segment, it has 3-lane segment, it has 6-lane segment, I mean everything. It has ROB, it has underpass, all possible combination of technology have been used in this construction of 6.1 kilometer. That time it cost something like 600 crores. This is the, you can just look at the proposed site. This is the start of the project. From this side, it's the end of the GT road. From GT road, you can say from your Amritsar or Peshawar to Calcutta, old GT road, it ends here, and this is start the project. Then there was a toll plaza, 16 plus 16 lane toll plaza. Then this is the main bridge here. There was a already bridge, Bali Bridge. Then this side, there are a number of viaducts, taking the different routes. And this is also at a place where you have the Howrah main cord line is coming to the Calcutta. So a lot of railway lines are also coming on the junction. So you have a lot of underpasses and ROBs. So total work, you can say the piling about 30,000 running meter. Now, it's a huge work. This is all matter of detail, which I will not go into the detail. You can see the main bridge. It's all precasting yard that was done. Total of number of segment are 240 number segment of the main bridge. Casting duration was 18 months. This job has to be completed in 18 months, total job. You can imagine another bridge at Calcutta took 20 years to complete. And this bridge was to finish, main bridge was to finish in 18 months. So you can imagine the kind of speed that was required to construct this particular bridge. This is the main bridge, you can see. This is the pylon. And this is how the segments are placed. I'll show in detail. This is the steering. This is the well cap. This is the well foundation. It is all placed for the well foundation. You can just look at here. This is the cutting edge towed by a separate mechanism, and this is how the well steering, added segment by segment. Look, this is the photograph. L&T was the contractor. This is the casting yard. 6-lane segment casting yard, and all the segments of 3 meter length was constructed here, and match cast technology was used first time in India. Match cast technology means like you have a different horizontal profile of the bridge, longitudinal profile is different. It is all the, you have different segments, but they have to form a specific profile. So unless the previous segment matches to the other segment, you cannot control the profile. So that is how the staging, you have to tweak every time to match the previous segment. So this is called match casting. And this is the span by span, you can just see. So not span by span, this is segment by segment. This is the truss supported on the pier. Then this is how the segment was floated and joined together with the help of stressing. This is the transportation. This is how it is to be lifted, taken to the between the piers, put it on the temporarily onto the supports. No release of load at this point. Then just when this is done, all they are in perfect line. Then we go for pre-stressing. After pre-stressing, we see there is a small curvature on the surface of the span. We see that the load is now self-supported. Then we remove the truss, and this is moved on another piers, like that. There was underpass, like in Dakshineshwar. There was a train already, means there were a lot of railway lines, and railway never allowed to stop their traffic because it's a huge loss to them. In running condition, we used all this, we undercut the embankments to facilitate the viaduct movement. And to cast the, to speed up the construction, the contractor was, directed to have a floating batching plant. It's first thing that you could have seen in India at that time, 20 years back, 21 years back, where all this is the floating barge. So this floating barge carry all this material, and it was done, casting was done simultaneously with the help of concrete pumps. This is the view of pylon work. This is how, this is a picture, this is a actual representation of the floating of the segment, 2-lane segment. It is a 2D segment, and there you see the pier, single cast pier in one go. That is why you see this kind of finishing. Accident do happen, it has happened unfortunately, but we have to carry on with that. This is the portal truss. You can look at the old bridge. This is the existing bridge, having both railway and road traffic. This is the 6-lane segment, concreting. And this is how the pylon, after construction of pylon, this is the cable, extra dose cable, this is the cable. This is the view of the finished bridge. So that is how that construction was done. And then there is another case study which we have done at Ghaziabad. Our CRRI was associated with the construction control, quality control of that particular 6-lane road at Ghaziabad. So there it was constructed by Navyoga engineers. So it is the first longest elevated road in the country. This is a 6-lane on single pier. This is also a very good construction. You can just look at the index map. This connects between Delhi from the Yamuna side, from the Gazipur border to Ghaziabad, 9 kilometer long corridor. So it's a 6-lane configuration, 2 into 11.1, 22 meter, having median of 1.5 meter, and project length is 9.3 kilometer. So total cost is about 1,000 crores. This is the typical cross section. You can see the 6-lane segment resting over the pier. This is how the one segment look like. So sequence, of course, construction of piles that has been explained to you. The open footing also at some locations. The pier, it is done in single pour. The entire cage was cast in one go. And there are tall piers also. It was done in 2 stage. The pier cap, all along the Hindon Canal. This is the Hindon River or canal, you can see. All along the Hindon Canal, this construction was done. So you can see the kind of subsoil conditions and the geotechnical investigation that must have gone to stabilize this foundations, like that. Here, same technology, match cast segment technology, 6-lane segment. This is the view of casting yard, and this is how all these segments were placed from the gantry at the top, like that. construction, look at the construction sequence. I mean, just look at the traffic. Traffic is going on. It's not that abroad also, we are in India also, our engineers are confident that, look, we take this challenge. Let us not stop the traffic. Because stopping the traffic is a big challenge in such a huge environment. Like you have the almost 60, 70,000 PCU traffic, like that. This is the casting of on ancillary works. Then this is ROB, 6-lane ROB. So ROB was composite construction. So it was done in a composite fashion, steel girders. It's on Hindon crossing, like that. Huge work. CRRI team was always available at the site for the quality construction and another construction control. This is the view of finished view of the elevated. So this is how you have to take the challenge. This is how the construction technology you have to improvise upon. This is the finished view, and with that I conclude my presentation. Thank you.